Hello, my name is Trevor and thank you for watching my video. The project for today is to create a 3D point cloud of Testudo on campus using the LiDAR module that we created. So the first step is, after generating the images, which I will show you in a minute, is to use PyCharm to gather that information and create the XYZ values. And then all that information is under Testudo. There are 27 different images that I collected. And so right here it was guitar, but now I am searching for Testudo, the folder. And so this one is just searching for all the JPEG images from Testudo. This second one is for the sake of creating a text file with all that information that we're collecting from the images. That way, later on, we can use MATLAB to create another 3D point cloud, which is a little easier to navigate, as described in an earlier video. Okay, so I'm going to start it off. It takes a little while, so it goes one at a time. So it's pulling, first it takes the first JPEG, and now it's at 319. It just continues on. It goes pretty slow. So here are the images that are actually gathered. Now if you look, obviously these trees are in bloom, which are very beautiful. But right now you can't see the laser, and I will explain why in a moment. But as we continue to move, now this is at the very end of the process because they're smaller numbers, but then it goes to 319. And so now you can see the laser, which right now it's on brick. And so this may be like little gaps in the brick, these little black spaces right here. We'll just keep moving forward, and it's the ground, and it continues to be the ground, and it's really hard to see. Great. This is ready, but I'll show you that in a moment. So right now it's still the brick, and then we're about to be at the podium, which is, I think this is the very bottom of the podium, and then we move on and you can't see it. And as we keep moving, you can start to see just little bits of the image. Right here is just a little line, and then right here is a little more, and you just keep going, and we're missing out on a lot of the picture right here. And which makes me very curious because students from previous classes have been able to do it, but they've also used a green dot laser instead of this red line laser, and so it's possible that the power there's a much more powerful output for the green dot laser, and so it's maybe a lot more visible, whereas right now we can't see it at all from the image. But as we keep moving, you can see a little bit, but it's probably not going to be picked up, and so that's going to be very clear in the 3D point cloud that we observe, which is right here. But again, it's very difficult to see what's going on from this 3D point cloud, and it's hard to navigate around. So I'm just going to X out of that, and we're going to move over to MATLAB. And so again, this test to results text file is very familiar because we just created that from the PyCharm file. And so we're going to switch this from guitar to Testudo. That way we're looking for the right data, and now we're going to run it. So essentially what this does is it's once again collecting all those XYZ values. Again, it says load in XYZ data, and that's all the data that was collected and published into this test results text file. So now this is again going to take a little while, so we can quickly navigate back to these images, but there's not much more to show for that. But again, we're missing a lot of the picture, and so I'm curious if this is going to be the same problem for a lot of people, if my line laser is maybe dimmer than others. Now, it actually is brighter than a few other of my friends' line lasers, and so I don't believe that's the case. And so moving forward with this course, interesting consideration might be that the course will need to have brighter line lasers, whether that's a different color or it's just a greater power output or outage. Not outage, output. All right, now this is the 3D point cloud. It's moving a little bit, and so there are only little dots, and that could just be a little bit of noise, because I don't believe that it actually picked up any actual points in the from Testudo, but it's possible that there are a couple that I missed. but for the most part, you can see just a flat surface. There's some bricks, but you can't see really much of the detail from the bricks. But then you have the testudo podium. I believe that's the M, and right above it would be testudo, the word, and then right above that would be testudo. And he's completely missing. You can't, because the camera didn't pick up any of the line laser, and so that's going to be a very difficult problem to overcome for a lot of students, I think, in this project. Now, uh, just to clarify, testudo wasn't the object that I was given to collect data from. I actually was supposed to collect data from another object that was on the very edge of campus, but I collected all this data at 3 in the morning, and so I felt pretty unsafe actually going to my actual object. And so for the proof of concept, to prove that I could collect this data um, remotely and not using like an in-house power supply or anything like that, I wanted to still collect an object, but from the safety of um, a location that's more in the middle of campus where more students are likely to be walking around. Again, this is just the ground, the surface. As you can see in the compared to a previous video, it still has this angle to it from the ground and this one right here, and it's still a 90-degree between them, but there's this angle which um, which I really want to look into fixing. And I've heard that other students have had this problem, and so somebody might have an idea as to what the source of the problem is. But I believe this point right here, no, this is just a point of rotation, but the LiDAR device was probably from a similar distance. Um, in fact, that actually could be the point where the LiDAR was collecting data, the camera. But again, Testudo is completely missing in this image. You can't see him. The sculpture that I was going to be taking an image of is bronze, so I would very likely have the same problem. So I'm considering actually either choosing a different object on campus or getting a brighter laser, but I don't know if there's going to be time because I've been looking through, and some of the brighter lasers you can't get very quick shipping unless you pay an extremely like extra, a much higher fee for that. But this is Testudo. I've learned a lot, obviously, from this. Whether that's just the fallbacks of using the line laser that we have, or even the shape of the ground compared to a flat ground that it should be, so the angle between that, and just recognizing a need to change that. There's a little bit of error right here. This line is lower than this line, and so I actually, after collecting all the data going up, I collected a few more points on the ground just to be sure I had over 20 points, and for some reason these are lower, so that means there's some sort of inaccuracy in collecting the data where, because which is interesting because the LiDAR device was in a fixed location, and so I don't know what might cause that, if that's an error in the app that I was using or something else, but that's something to look into also. But this is Testudo. It's a 3D point cloud. I really enjoy these views, not so much for the Testudo one, but it's for some reason my computer's not allowing me to rotate them today. Oh, here we go. So that's Testudo, and it just wanted something to turn red, which is part of the ground right here, but there's nothing important about that part. And yeah, and this is just another iteration of that, or another way of visualizing that. But anyway, so that is how you create a 3D point cloud. And now I could have gone a lot more in detail with the code and everything like that, but to keep it shorter, that is essentially how you can create JPEG images with a line laser. And just reading that line, you can pull XYZ values from that image and actually create a 3D point cloud. And as you can see in that image, which I just closed out of, all the lines are very vertical or horizontal, which obviously those all represent the line laser. Well, thank you anyways for watching my video. And I believe that concludes homework 6.